When we look at the sky at night, we see thousands of small dots of light. These dots are a large collection of stars and planets. The longer you stare, the more dots you'll see. From Earth, all these dots might seem similar, but they are not all made of the same materials. Today's episode is based on a question from curious little Emma. What are planets and stars made of?
Beautiful question. By eye, planets look almost identical to stars. But if we look at the ingredients of stars and planets, they're actually completely different. To explain what I mean by that, we have to take a look into the place where stars are born. So buckle up, we're going on a trip to the interior of a galaxy. Stars were born within molecular clouds of gas and dust throughout young galaxies. Molecular clouds are dense clouds of gas and dust that are located in between the stars. Molecules are able to form within these clouds. The most common molecule that is being formed is hydrogen. When the dust and the gas slowly starts to clump up together, it will start to attract more and more mass until it's heavy enough to collapse under its own gravitational attraction. While collapsing even further, a star will be born. Slowly, leftover material from the cloud starts to rotate around the newborn star. This causes a rotating surrounding disk. Planets are originating from the material in these rotating disks. So basically, planets form from the same materials as the materials from which the star was made. As all stars form from these so-called molecular clouds, does that mean that all stars look the same? The answer to that is no. When we look from the Earth, stars might appear as identical bright dots. But as we look at them from close by, we can see that they're actually different, depending on how much gas and dust the environment contained when the stars were born. Stars can start their lives from different sizes. Not all stars are born at the same moment. They all have an age that can be determined by looking at the mass and the amount of light that is emitted by the star. Stars start to emit more energy once they grow older. All the stars that we can see in the night sky are definitely not identical and consist of different ratios of ingredients. To understand a bit more about the ingredients of a regular star, we will look at the most well-known star of them all, our Sun. We can think of the Sun like an onion. You might think, what? An onion? The only thing that a star and an onion have in common is that they're both sort of round? Well, actually, we want to compare the Sun to the inside structure of an onion. When we slice through an onion, we can see that it consists of multiple layers. Stars also consist of multiple layers, where the most inner layer is super hot and the most outer layer is less, but still very hot. Let us take a closer look at the layers of the Sun, starting from the inside. The most inner layer is what we call the core of the star. The core consists of pure helium atoms. With a temperature of 15 million degrees Celsius, it's the source of the Sun's heat. Outside the core, 70% of all the heat is radiating out towards the outer layers. Here we find loads of hydrogen. This is what researchers call the radiative zone. The outer layer, also consisting of hydrogen, is the convective zone. Here the heat is not radiating out anymore, but it's transported outwards by the gases of the layer. Researchers have always assumed that the composition of the Sun and the stars would be much like that of the Earth. However, that's not the case, as the Earth mainly consists of iron and oxygen. Nowadays, we know that about 73% of the mass of the entire Sun is made of hydrogen. The core consists completely of helium, which is about 25% of the total mass of the Sun. This only leaves 2% for other ingredients that can only exist in the outer atmosphere of the Sun. Cool! Or shall I say hot? So now we know what kind of ingredients are part of a star, but now we want to see what kind of ingredients are in planets. That's what we're going to discuss in our next episode, so stay tuned.